Hello, my name is Toni Smith, and I am from the American Institutes for Research. Today, I'm going to talk about ways to increase opportunities for students to learn and ultimately increase achievement through math instruction. I'll begin with an overview of the research to support a focus on improving math instruction. Then I will describe two examples of projects that draw on this research and that have experienced success in improving instruction and student outcomes. And I'll close with a summary of the discussion. So let's dive in. Why should we focus on instruction as a mechanism to increase opportunities for math learning? As has been reported many times, student math achievement is not as strong as desired. Proficiency rates are lower than hoped overall, and we see differences in student performance along racial, ethnic, and economic lines. Moreover, math performance during and after the COVID-19 pandemic is weaker than in prior years, and equity gaps are widening. Improving instruction is widely recognized as a key mechanism for raising student achievement. Research shows the importance of teacher quality for student achievement, and states and districts have allocated significant resources toward professional development aimed at improving instruction. So what are the features of math instruction that we should focus on to improve student learning? Math educators have argued for decades that students need more opportunities to deeply engage with math content. Specifically, they need opportunities to reason about the underlying math concepts as well as procedures, explain their mathematical thinking and respond to others' thinking, and solve math problems that require more than rote application of procedures. Teachers can provide these opportunities through their use of questioning and math discourse during instruction. And there's evidence to suggest that using questioning and discourse in these ways is positively associated with student achievement. And these approaches are associated with improved math outcomes for traditionally underserved students. So how can we support teachers in developing their skill in questioning and discourse facilitation? Research on teacher development suggests that to shift their instruction, teachers need opportunities to learn specific research-based instructional strategies to support student learning and engagement, not just broad principles or theories of instruction. And they need opportunities to practice these strategies, reflect on their effectiveness, make modifications, and try again. So for math, this means that teachers would benefit from learning about specific questioning and discourse facilitation strategies, and then practice using and improving those strategies over time. The two projects that I'm going to talk about draw from this research base in supporting teachers to improve their math instruction. Both focus on questioning and discourse facilitation strategies and provide opportunities for teachers to practice and improve those strategies. We'll start with the first project, Simulated Instruction in Math Professional Development, or SimPD. SimPD is an innovative professional learning program for teachers to learn questioning and discourse facilitation strategies that are intended to promote student engagement in math learning, work with other teachers to collaboratively practice those strategies in a simulated classroom where avatar students respond to teachers in real time. And you can see the simulated classroom and the avatar students at the bottom of the screen, and receive support from a coach who is trained by AIR to lead the PD activities. And those coaches are either district or school-based, so they're local to the teacher's context. The program focuses on the posing purposeful questions and facilitating meaningful mathematical discourse strategies that are outlined in the National Council of Teachers of Mathematics Principles to Actions publication. Specifically, the program emphasizes using different types of questions to gain insight into student thinking and sequencing those questions to advance student understanding, which both fall under that first strategy, posing purposeful questions. The program also emphasizes ways to encourage students to share, respond to, and make connections among different approaches to solving math problems, which falls under that facilitating meaningful mathematics discourse strategy. The program activities are organized into modules, each of which focuses on one of those strategies outlined on the previous slide and includes a series of workshops, some practice sessions, and a group debrief. And as mentioned earlier, these activities are facilitated by a district or school-based coach who is trained and supported to lead the activities across the modules. So let's take a look at these program activities more closely. Each of the modules begins with a 60-minute pedagogy workshop in which teachers learn about the key components of the strategy that's the focus of the module and analyze a video recording or a transcript of instruction that illustrates that strategy. So they talk about what this actually looks like in practice. Next, teachers meet for another 60-minute workshop to prepare to practice the strategy with a specific teaching scenario in the simulated classroom. In each scenario, students have been working with a math task in small groups, and the teacher has circulated during small group work to see how students are approaching the task. The simulation then starts as the teacher leads a whole group discussion that builds from the student work to advance student understanding. During the workshop then, teachers discuss the task in the scenario, review examples of student work that were produced during the small group work, and plan how they will use the instructional strategy that's the focus of the module to build from the student thinking and improve understanding with a whole group discussion. Teachers then try their plan in the simulated classroom during practice sessions. As they do, they interact with student avatars who are operated by a Sims specialist who's a live person in real time. Teachers join the simulated classroom via a Zoom meeting, and they can see the simulated classroom and the student avatars, but they can't see the Sim specialist. The Sim specialist can see and hear the teacher. So what's nice about this is that teachers can try their plan, stop at any point, reflect, modify their approach, and try again as needed without the avatar students being affected by the initial experience. In other words, the avatars don't remember what the teacher tried first. And so that allows the teacher to try again or pick up at different time points and try something new. The Sim specialists who are operating the avatars are trained to respond to the teacher's actions in ways that are consistent with research on student learning. So the experiences that the teachers have are realistic and consistent across sessions. There are 2 practice sessions in each module. During the first practice session, teachers work as a team with their coach, taking turns playing the role of the teacher and working collaboratively to reflect and modify the approach. Then after they've worked as a team, teachers have another practice session to do the same thing, but they're working individually with their coach at that point. So this is what the teachers see as they interact with the avatars. As in a Zoom meeting, they see themselves, so you can see the teacher in the upper right-hand corner. But instead of seeing a person on the other end, they see the simulated classroom and the avatars. The Sim specialist sees and hears everything the teachers are doing and responds accordingly, both with physical movement for the avatars and with responses to the teacher's questions. So the avatars can raise their hands, they can look at each other, and they can work in small groups, etc. So it really does provide a simulated experience of the classroom environment. Finally, after teachers have practiced the focal strategy, they meet as a team with their coach to debrief and reflect on the experience. During this group debrief, the coach guides a discussion in which teachers share what they learned and discuss ways to use the strategies in their classrooms. There's one of these debriefs at the end of each module. So that gives an overview of the program. Let's look at what we are learning about its impact on instruction and increasing opportunities to learn more broadly. We have been studying and are continuing to study this SimPD program. We first conducted an initial pilot study, which was supported by Lynn and Charles Schusterman Family Philanthropies. In that initial study, we were interested in understanding implementation, teacher perspectives of the program, and the program's impact on classroom practice. The study focused on grades 4 to 7, and the PD included 2 modules, one on posing purposeful questions and the other on facilitating meaningful math discourse. The PD, with 2 modules, was designed to last about 10 hours in total, and the study included 16 schools across 3 districts in 3 states. We randomly assigned schools to treatment or control conditions and compared outcomes from the 2 groups. So that initial pilot study is now completed, and we're in the process of conducting a larger efficacy study of the program, which is supported by the Institutes of Education Sciences in the U.S. Department of Education. In that second study, we're still interested in understanding implementation and impact on classroom practice, but doing so on a larger scale. We're also interested in understanding the impact on student achievement. And this project has a narrowed focus on just grades 4 and 5 and includes 3 modules for about 15 and a half hours of PD. So we went from 2 modules to 3 by breaking the posing purposeful questions module into 2 different parts. This larger efficacy study will include 60 schools from across the country, and the schools will be randomly assigned to treatment or control conditions as in the first study. So we're just getting ready to start implementation for that second study, so I'll share results from the initial pilot study, which is now completed. To investigate implementation and teacher perspectives, we collected coaching logs, which document all of the activities in the PD sessions, as well as video recordings of those PD sessions, which we looked at. We also collected teacher reflections on the program. To investigate impact of the PD on classroom practice, we collected observations of math lessons in teachers' actual classrooms, and we did that for treatment and control teachers. We collected those observations at 4 time points: in the fall before the PD, in the winter after the PD, and then in the spring at the end of that same school year. And then we came back and did observations in the following fall. The observations were conducted via video, so they were video recordings of teachers' lessons. And we coded them with codes drawn from the Mathematics Scan or MScan observation rubric. And we really focused on codes that were aligned to the PD focus. With respect to implementation and teachers' perspectives, we found that the PD program activities were implemented as intended. On average, the activities lasted within 10 minutes of their intended length of time, and over 95% of the segments within each of those activities were implemented. Overall, 19 of the 21 teachers who remained in the study completed all of those activities, so it was really well implemented. And teachers really had positive impressions of the program. And so I've included a quote here from one of the teachers. I'll give you some time to read it. So teachers really did appreciate this opportunity to try things out, pause, reflect, and try again. In addition, we found positive impacts on most of the MScan codes that were focused on teacher actions. The graph here shows the 7-point scale for the MScan codes focused on teacher actions, with a 1 to 2 representing a low score, a 3 to 5 representing a mid score, and a 6 to 7 representing a high score. And you can see that the codes here focus on questioning and discourse facilitation moves. The light blue bars represent the average scores of the teachers who participated in the SimPD program, and the dark blue bars represent the scores of the teachers who did not participate in the program, and in other words, the control group. The stars represent a statistically significant difference in scores. So on all of these codes, we see the scores higher for teachers who participated in SimPD than for those who did not. And moreover, most of these differences were statistically significant, which are really great findings. We also found positive impacts on most of the MScan's codes that were focused on student actions. And here we see a similar graph with codes focused on student activity in the classroom. On all but one code, scores were higher in classrooms with teachers who participated in SimPD than in classrooms with teachers who did not, and the differences were statistically significant on those codes. The two groups scored similarly on that first code on the graph here, students engaged with a math activity, and this is actually a positive result because it means we weren't just picking up on the fact that students were engaged in the classrooms overall. They were in both groups. What we're seeing, though, is that there were differences in the way students were engaged. So students in classrooms with teachers who participated in SimPD were talking and sharing their math thinking more than in other classrooms. They were showing depth of explanation and justification and so on. So these results show a lot of promise for the SimPD program in improving instruction, increasing opportunities to learn. And we're excited to learn more about this program and see if it translates to impact on student achievement in our current study. So now I will switch gears to another program that uses a very different approach to providing teachers with opportunities to practice and improve specific questioning and discourse facilitation strategies, the Florida Network for School Improvement, or the FNSI project. FNSI is a networked improvement community in which teachers and researchers work together to test and refine instructional routines aimed at increasing math proficiency. And those routines focus on questioning and discourse facilitation. The project is supported by the Bill and Melinda Gates Foundation. So who's involved in this project? The project's led by what is called an intermediary, which is AIR. And then as the intermediary, we are responsible for designing and organizing network activities, which include the use of inquiry cycles to test and refine instructional routines, as well as opportunities to share learning. As the intermediary, we also track progress over time, making improvements to the work as needed. We work very closely with a district in Florida on this project. And within that district, we work with most of the high schools and a few middle schools. You can see that district involvement includes district administrators, specifically those that oversee secondary education and math, as well as the research department so that we can have some data sharing agreements, as well as staff from the participating schools. And within the schools, we work with the principals and school administrators who oversee math. We work with the school math coaches in those schools. And then in the high schools, we work with the Algebra 1 and geometry teachers. And in the middle schools, the middle grades math teachers. The work is focused on increasing the percentage of Black and Latino students and students experiencing poverty who are proficient in math by the end of 10th grade, as indicated by passing scores on the state end of course Algebra 1 and geometry tests. So as you can see, this is largely a high school aim, and high schools are working toward that aim. But we also have, as I mentioned, some middle schools involved, and they're also working to support this overarching aim. This picture shows the network's theory for how we might make progress on the aim. It was developed collaboratively between AIR and the administrators and educators in our partner district. So on the left, you see that the aim that we looked at on the previous slide. And in the middle are what the network hypothesizes can drive progress in meeting that aim. If we can improve the green boxes, we think we will make progress on that blue box. And so within those green boxes, we see math instruction, positive caring classroom environment, student beliefs and ability to learn and do math, and middle school proficiency. And so that's where the middle schools come in. The math instruction box is much bigger because that's really where a lot of the work is targeting. And specifically, we're looking at ways to improve math instruction so that it provides opportunities for all students to access and engage with rigorous math content. And we're doing that through the tasks and examples that are being used so that they balance understanding and fluency, and through instruction that provides opportunities for students to solve, communicate, argue, and evaluate mathematical thinking. To make progress on those green drivers, the network recognizes a need to make changes in instruction. So those changes are using evidence-based instructional routines that hold promise for making the improvements described in the green boxes. And so you see in the salmon color box, the change ideas, which are the instructional routines that would drive the green boxes, which would then help us to make progress on the blue. Teachers test and refine those change ideas or instructional routines using inquiry cycles, or more specifically, plan, do, study, act, or PDSA cycles. And so in a PDSA cycle, you plan, create a plan where you propose a change and you decide how you're going to test it. Then you do, so you try the change, collect data, and reflect on what happened. You study, so you analyze the data that you collected and you capture learning. And then you act. You decide whether the change idea is in good shape and you want to just adopt it as is. Or, and this is the most likely thing that comes out of this, is that you adapt it. You figure out what's the way that you want to make a change to the routine, or you abandon it altogether because it really is not effective. So applying that pre-DSA process to the FNSI work, Teachers are testing and refining instructional routines that support student engagement with rigorous math content in the ways described in that large green box. Specifically, these routines use different kinds of questioning approaches, which includes the use of high-quality math tasks as well as high-level questioning. And the routines emphasize discourse facilitation, which includes structures to support small and whole group discussion. And so, for example, teachers might be working on a small group talk protocol where students explain their thinking during math explorations. Or there might be a discussion protocol that they're working on where students take turns justifying their work while others offer critiques to improve the justification. Or there might be a formative assessment pause where teachers identify students that need more support, and then a process for engaging with them using questioning to give that support. As they try out these routines, the data that they collect is around student engagement and student math work. So they ask a few questions for students to share how they felt about their engagement in the routine and if it was valuable or it was helpful for their learning. And then they also submit some work on a math question or math task that the teachers then analyze to see how the routine connected to their math learning. So at the network level then, how this all fits together is that we have subject-specific teacher teams. So the Algebra 1 teachers, the geometry teachers, the middle grades teachers work together as an improvement team. They select an instructional routine to test and refine as a group. They use PDSA testing to refine the routine, and they're supported by AIR math improvement coaches in that PDSA process. So identifying the routine, looking at the data from that routine, and trying to make decisions about the act or the next steps before they cycle through and try it again. AIR also works with others in the system to support teachers' improvement work, that PDSA work, and ensure coherence with the overarching initiatives of the district so that everything aligns. And that includes the folks in the schools who are the math coaches, as well as the school administrators who oversee math and the district leaders. And then the network meets periodically as a full group to share learning. The project just finished its 4th year, and we've been learning a lot over time and making improvements. In terms of outcomes, we have been meeting our targets for increasing the percentage of students who pass that state test by the end of 10th grade. It's a slow progression, but we are seeing improvements, which is exciting. Moreover, our teachers believe the network has improved their practice and student learning. So they really do see the value in this work. And students have been reporting feeling more comfortable and valued in math class, which is a great outcome because it may mean that they have more opportunities to learn. They feel valued and can learn the math. I put just a graphic here of the results from our most recent teacher survey, where you can see that teachers either strongly agree or agree that the network is making a difference, that these change ideas or instructional routines will help improve math proficiency, and that they really feel like the work is helping to improve proficiency overall. So that's a great outcome. So in summary, this focus on improving math instruction seems to hold promise, both from research and examples that I shared, for increasing student opportunities to learn and for math achievement overall. And in particular, some promising aspects of this work are on supporting teachers to improve their use of discourse and questioning strategies, and offering opportunities for teachers to try the strategies, reflect on implementation, make modifications, and try again. And there's several ways to provide these opportunities. I shared 2 examples, but there are many, many other examples out there. Still, more work is needed to understand the impact of these and other approaches on a broader scale. So I'm excited to see what we can continue to learn from these and other projects focused on improving math instruction to increase student learning opportunities in math. Thank you very much. Hi, everybody. I'm Toni Smith. You just heard my presentation, and we are open now for questions. If anybody has any questions, go ahead and please put them in the chat. Any clarification questions on the various programs? more information on the avatars and how they work. They're pretty exciting. I've gone through that, and I'm a former teacher myself, and I really love the opportunity to kind of try some things and then start all over again or pick back up at a certain point. And it's a pretty neat program. I wish that I had that opportunity as a teacher to do that, because often I would start down a path and then realize, oh, I need to change something, and this gave the opportunity to do that. And then the FNSI project has been great for teachers to work together and think about what kinds of routines they might do in their class, which is, excuse me, been really great. Let's see, we got a question. Are these protocols done side by side with the state mandated curriculum? So for the SimPD project, that all happens sort of outside of the classroom. So those are just focused on general pedagogical moves and practices. When they do the practice in the simulated classroom, they do that with some specific content. And that content is content that's pretty common. Like it's like adding fractions and those kinds of things to try to do that more conceptually. So it's not tied directly to a curriculum, but it's more broad topics that teachers would be teaching in their classroom. I will say that could be another iteration of that project, is to make the simulated classroom scenarios directly connect to the curriculum. We've just been in a lot of different districts and we don't have it tied to a particular curriculum, but that could be a next step. In FNSI, we do work directly with the teachers to try out those routines using their curricular materials. So part of those PDSA meetings is to examine and reflect on how things went when they tried the routine the first time. But then we look ahead to the next test or trial, and we look at the lesson they want to do it with. We identify questions from that lesson that would be useful to use, or tasks that would be useful to use in that when they're trying out the routine. So it is directly connected to the textbook that they're using on a regular basis. Let's see, we have another question, which is about were all the teachers involved or those who did volunteering to improve their techniques? Good question. In the SimPD project that I explained with the avatars, those teachers were volunteer teachers in schools. And in many cases, the entire team of teachers within the school signed up to do the PD program. In FNSI, they are all encouraged to participate. So at the schools that have signed on, they are anticipating that the teachers who teach the focal courses in those schools, which for high school would be Algebra 1 and geometry, and for middle school, it's middle grades math, would participate as a team. And it's helpful because it actually connects into the PLC work that they already do as a team in their planning and those kinds of things. So, so we didn't specifically ask for volunteers, but the teachers are encouraged to participate, and it blends pretty nicely into the work that they're already doing. Great questions. We've also in that project heard from teachers that it has that Florida project with the improvement in the PDSA cycles, that has also played a role in just their working together collaboratively as a team to plan. Those are great questions. Any more questions? Will the SimPD program be widely available? Great question. As I mentioned, right now, we are in the process of doing a larger efficacy study with some funding from the U.S. Department of Education and the Institute of Education Sciences. We're actually recruiting right now for districts for the next year's implementation. So if folks are interested, let me know or get in touch with me, and we can talk about whether or not you might want to sign up for next year. But after that, once we kind of understand whether or not it's having an impact, I think then that's an open question of whether we would try to make this a broader, more widely available program and try to gauge some interest in that potentially. It's a great question. Was there a reason why certain schools were chosen? And okay, so I'll talk about both of the projects. For the SimPD project, we, in the pilot study and then now for the efficacy study, we're doing general recruitment outreach to districts, and we're looking for districts that may need more support or have us, we're not necessarily going to the high performing districts already. We're looking for districts that maybe aren't as high performing, or individual schools within that. So that's sort of our only criterion. The FNSI project, that project we partnered directly with district leaders from the school district that we're partnered with. And they were really interested in all of their comprehensive high schools participating. So we kind of left it to the district as to who they thought might be good partners in the project and would be interested. There are a couple of high schools in the district that aren't directly participating, and they've got sort of other foci, but they sort of identified the schools that they thought would be good to, work on this project. And then we talked to those schools and they were interested in joining. And similarly with the 2 middle schools, the district leaders thought about who might be good partners in the project and would, benefit from additional supports like this to work with teachers. And then we talked to them and they were interested in joining. Ah, great. I will write that down. A school district is interested. We will follow up. It's Cynthia. Try to see if I can follow up with you afterwards. Great. We're just in the process of looking for districts so then that would start in the following school year. So we got plenty of time to get things set and ready to go and have conversations for whoever needs to weigh in and hear more about it. That's great. Any other questions? Trying to think if I can anticipate questions that I've been asked over the years for the various pieces. I can talk a little bit about the teacher experience with the avatars oh, thank you, Cynthia. We do have an opportunity. Sorry, just writing this down. We do have an opportunity before teachers start working with the math, with the avatars, for teachers just to interact, because it is a different kind of thing, right? You sort of are in this different kind of an environment. So we just have an opportunity for teachers to first start by talking to them. Well, what did you eat for lunch? What did you do yesterday? Sort of just a general get to know what it feels like to have that conversation with the avatars. So they have that opportunity first and see that avatars can raise their hands, that they can turn and talk, and then get into trying out the math piece. So they get the little bit of comfort, just sort of getting that immersed in that environment. Okay, so a question about the districts in the SIM pilot, where they have substantial size. I would say that we had some mid-sized districts, and they were in different parts of the country. They weren't all in one space. And then we did have a couple in some rural areas. And we've actually been talking to some other folks who this might be an interesting opportunity in particular for rural teachers, who, because there's that opportunity to do it virtually, so they can connect with other teachers. And right now for the current study, we're open, broadly across the country too. So interested in identifying schools that represent different locations. The next question, would you be thinking of trying to implement this program at colleges? Good question. I believe that this, and my assumption that this is the SIM study with the avatars. I believe that the technology was first developed at a university in Florida. It was called Teach Live at the time, and it was being used with pre-service teachers. So prior to their working in practice. And that technology, you can also, right now we are focused on sort of the facilitation of math instruction, but you can also work with the company and with the avatars to be focused on other aspects of instruction. So there were opportunities, and I think a lot of times with teachers who are learning to become teachers, there's, you can enter into those simulated classrooms where the focus is on managing student behavior. Or I think initially there was some development around supporting students who have special needs. And how do you do that? So there's different things you could focus on in your practice. And I do know of some different colleges of education who are using it with their pre-service teachers to focus on various aspects of instruction and give them practice before they go into the classroom. Okay. Question was, did the person understand correctly that the next recruitment cycles is solely on performance based? It's not. We're looking across the country. We definitely are not. We're trying not to be in places that are already high performing districts. And we would ideally be in locations that have some diversity in student populations. But we're definitely, so that it's not just on performance, but we're trying to be sort of more broad. I think you all maybe have access through the overarching, you can see who the attendees are, and my email is there if you have follow-up questions. If not, I am tsmith@air.org if you have any other questions about these projects or anything in general. Spent a lot of time thinking about math teaching and learning. I love talking about math teaching and learning and work with teachers. So, thank you, Martin, for putting that in there. Okay, well, thank you everybody for the great questions, and please do follow up with any additional questions that you might have or conversation.